All right, here we are, the rational root theorem part 1. A lot of examples to go through, so I'm splitting up into 2. If you're watching this, then that's good. You should be watching this right now. I looked at the video for yesterday, the Pascal's triangle examples, and only 3 views were recorded, so that tells me that the majority of people did not watch it. Unfortunately, that's all going to be represented on the test. So you're going to have to learn at some point, and I'm not going to take class time to reteach it, so you're going to have to use your own time to go ahead and learn that. So if you are at this page, then that's good, because you're actually going to learn something that's going to be on your test on Monday and Tuesday. Okay, so here's your learning target right here, and I've laid out your table of contents, so you'll need to take notes on this entire thing. Just go ahead and take notes on this entire thing. Pause the video now so that you can just write this stuff down off the screen. Okay, so you should have written this stuff down here, so let's just go ahead and keep moving on here. So we got to ask ourselves, question, how do we find the roots of a polynomial equation when we can't easily factor it, okay? So we've been able to fact quadratics, so polynomials with root 2, okay? And we usually have used diamond method. But what if it's higher than root 2? What if it's a root 3 or a root 4? How do we go ahead and factor those and find the roots? Well, there's actually something we can do, and it's called the rational root theorem. So the rational root theorem states that all rational real roots of a polynomial can be found by dividing the factors of the constant term, so that's this term here, by the factors of the leading coefficient. Okay, so the leading coefficient is right up here, right? The coefficient is the number before the variable. So the rational roots theorem states that all real rational roots can be found by dividing the factors of the constant term by the factors of the leading coefficient. And these are all possible roots. So not every one of these that we find is actually going to be a root of it, but all the roots will be contained within that set that we come up with, okay? Within that set. So go ahead and write down this blue stuff here. Pause it, write it down. Alright, so let's look at an example now. So it says, find all rational roots for this polynomial. So we're going to go ahead and list the factors. Just like it said in the thing, I'm going to list the factors of 1. Well, the only factor of 1 is 1, right? Well, now we can list the factors of 20. So first and foremost, we have 1 and we have 20, right? Then we also have 4 and 5. And of course we have 2 and 10. So they're all the factors of 20. So we found the factors for the leading coefficient. That was over here. And then we found the factors for the constant, okay? And in our definition it says that all real rational roots of this polynomial can be found by dividing the factors of the constant term by the leading coefficient. So these are the numbers that are going to be on top, and down below is going to be this number right here. Since it's only 1, it's just going to be 1. So let's look at possible roots here. Extend the page. Okay, so our possible roots then have to be this. I'm just going to go ahead and list the factors. I'm going to start with our first factor here, which is 1. So one of them is going to be 1 over 1. And this is actually going to be a plus or minus. All of these are going to be plus or minus. So I'm going to have plus or minus 1 over 1. Okay. My next one, I have 20, okay, 20, so I'm going to have plus or minus 20 over 1. Remember, I'm using the factors of the constant over the factor of the leading coefficient. Then I have plus or minus 4 over 1, and then plus or minus 5 over 1, plus or minus 2 over 1, and last but not least, plus or minus 10 over 1. Okay? So that's all I've done here, right? I put the leading coefficients, the factor of the leading coefficient on the bottom, and I put the factors of the constant term on top. I can actually just quickly rearrange these so they're in order here. So I have, that's going to be my biggest one, right? 20 over 1 is 1. Okay, so I'll just put, that didn't divide up like I wanted. But if you just move this one over there, you could get this in order. Okay, so you can put those in order. So what this tells us is that the roots of this polynomial are either going to be positive 1, negative 1, positive 4, negative 4, positive 5, negative 5, positive 2, negative 2, positive 10 or negative 10, positive 20 or negative 20. So it's going to be one of those 2, 4, 6, 8, 10, 12. The roots are going to be any of those 12 roots, okay? The real roots are going to be within those, okay? It's going to be one of those 12 numbers there. One of those 12 numbers, okay? So that's our first step. We want to be able to come up with these real roots. So let's do some practice problems together. All right, so it says, find all possible rational roots for the following polynomials. Okay, so let's just go ahead and do what we did before here. So I want to look at the leading coefficient. Remember, if there's nothing there, it's just going to be 1. So let's find the factors. Okay. I'm just going to copy and paste that so I can have that over here, because we're also going to find the factors of 28. Okay, so let's see here. So for the factors of 1, once again, we just have 1. Let's look at the factors of 28. So we have 1 and we have 28. We have 2 and we have 14. And last but not least, we have 4 and we have 7. Okay, 4 and 7. If you need to, go ahead and use a multiplication table, and that should help you find the factors of 28 or the numbers that get a little bit larger here, right? All right, so now that we've done that, we are going to be looking for the possible rational roots. Okay, the possible rational roots. So the possible rational roots, remember, we're going to take these factors of the constant, okay, and we're going to put them over the factors of the leading coefficient. So in this case, here's what we have. We have plus or minus 1 over 1, which is just 1. I'm going to put these in order 2. So I'm going to give them an exercise, 2. So I'm going to do plus or minus 2 over 1. Okay? And then I'm going to have plus or minus 4 over 1. 4 being my next highest factor. Okay, then we have 7, so plus or minus 7 over 1. And then plus or minus 14 over 1. And then finally plus or minus 28 over 1. Oops, sorry, my 8's a little messed up there. Alright, so once again, what this tells us is that the roots, okay, this polynomial is going to have roots of either -1 or +1, -2, +2, -4, +4, -7, +7, -14, +14, -28, or +28. Okay, the roots are going to be found within that set of numbers. Alrighty. So go ahead and try to do this yourself with this one. Okay, pause this video. Try to do this. So remember to look at the leading coefficient. Look at the constant here. Look at the constant. Look at this negative. Okay, I'm sorry. Just look at the 10. Just look at the 10. Disregard the negative. Look at the 10. Find the factors of each, and then go ahead and write them out. Factors of the constant on top, okay, over the factors of the leading coefficient. Okay, so you should have done this at this point, and let's see if we get the right answers here. So the factors of the leading coefficient, again, 1. Factors of 10, 1, 10, 2, 5, which means that we have possible rational roots of, same process, plus or minus 1 over 1, right? 1 over 1. Now I have plus or minus 2 over 1. I have plus or minus 5 over 1. Okay? And finally, I have plus or minus 10 over 1. 10 over 1. Okay, so hopefully you guys arrived at this answer. It's crucial that you can get to this step, because if you can't get to this step, then you're not going to be able to do the rest of this. All right, go ahead and start watching video 2 now. Video 2.